So today our question is, see, f is the function that is this is your domain and this is your codomain, that is real number. G, it is a function. F, it is a greatest integer function. So let us check the continuity of the f function because it is a greatest integer function. So here, because your domain is x minus half less than equal to 2, because your domain here is this, because this is your domain, so your domain is this. Now squaring both sides, I am going to get 1 by 4 greater than equal to x square less than equal to 4. Now the most important point here is that I am going to consider this as a greatest integer function, this as a greatest integer function. So here this must be an integer. So let me consider the nearest integer of 1 by 4 is 0 and less than equal to 4. Now if that is because minus 3, so minus 3 adding minus 3, that will be x square minus 3 less than equal to 1, because we know that this is a greatest integer function, because this is a greatest integer function. So our integers will be minus 3, minus 2, minus 1, 0 and 1. These are our integers. Now let us take case by case studies, that is considering case 1, case 2, case 3 like this. That is case 1, that is your x square minus 3, first it is less than equal to 3, it is equal to minus 3. This for first case, that is your greatest integer function is equal to minus 3. For this greatest integer function is equal to minus 3, that means x square minus 3 is greater than equal to minus 3 and less than minus 2. Now adding 3 to both sides, 0 less than equal to x square less than that is 3, this will be 1. So 0 x and less than 1. For in the interval this, your result will be minus 3. In the interval this, your result will be minus 3. Case 1, in this interval, your result will be minus 3. So now case 2, in case 2, we are considering it that x square minus 3 that is equal to this is a closed interval, sorry, minus 3, this is a closed interval, let us take minus 2. So in this case what happens, again your x square minus 3, this must be greater than equal to minus 2 and less than minus 1. So here adding 3 to both sides, 1 greater than equal to x square less than 2. So 1 greater than equal to x less than root 2. In this interval, your greatest integer function value will be this minus 2 in this interval. Again, I am moving to case 3. In case 3, it is x square minus 3, it is equal to minus 1. So in this case here again x square minus 3, it will be greater than equal to minus 1 less than 0. Adding 3, we are to all the sides, we are going to get x square and this is 3, taking square root both sides, so this will be equal to x less than equal to 3. So here we find that in this interval your greatest integer function's value is minus 1. Similarly, I am going to case 4. Here your case 4. In your case 4, that is your greatest integer function x square minus 3 is equal to 0. So when it is 0, so it is x square minus 3 is greater than equal to 0 less than 1. So here will be 3 less than equal to x square and less than adding 3, 4. So here this will be root 3 less than equal to x less than 2. So in this interval your greatest integer value is how much? 0. Now your case 5, if you go for case 5, 4. Now case 5, here your case 5, that is x square minus 3 will be 1. So your x square minus 3 will be greater than equal to 1 and less than 2. less than 2. If we add 3 both sides, so here will be, this is 3 add 4 greater than equal to x square and less than 5. So this will be 2 greater than equal to x less than root 5. So our limit is because our limit is up to 2. So for x is equal to 2, your answer will be for x is equal to 2, your answer will be 1. For x is equal to greater than, your answer will be 1. So this is the greatest integer function. So I am going to repeat it again. So what is the case that we have the integers, because this is the greatest integer, the integers are this. For -3, your limit will be this, and the x within this range, within this x value, your y, that is your greatest integer value, will be -3, and within this range your greatest integer function value will be -2, and within this range your greatest integer function y, that is your value, will be -1, and within this range x, your value will be 0, and within the here our maximum limit is 2, so we will consider here is equal to x is equal to 2. For x is equal to 2, it is 1. So let me draw the graph now. So let me draw the graph here now. If I draw the graph, let me, you see the graph here. Because your domain, your limit is from here, that is -half, this is -1, -half, and then 1 somewhere here I am taking, and 2 somewhere here I am taking, and your root 2 will be somewhere here, and your root 3 will be somewhere here, and so -1, -2, and -3. So here, and this is 1. So what do we get here? That is in the this x value 0, 0 and 1, your value will be -3. That means your 1, that is, it doesn't touches 1, but it will touch 0. Your greatest y value is -3, and again from 1 to root 2, your value is -2. So from here 1 it will touch here, and root 2 it will not touch here, so it will be how much? -2. And from root 2 to root 3 it is -1. From root 2 to root 3 it is root 2 to root 3 it is -1. Now from this data, let me draw the graph here. From this data, let me draw the graph here. So here, this is your graph. So here you see that because your limit, your domain limit is from -half to 0. So let 1 will be somewhere, -1 here, and -half will be somewhere here, and 1 let us take somewhere here, and 2 let us take somewhere here. Here will be root 2, and here will be root 3 somewhere here. So again here this is -1, and then -2, and then -3, and here somewhere it is 1. So within this range, that is x 0 to 1, your greatest integer y value is -3. So here this will be -3. So now again from 1 to root 2 it is -2. From 1 to root 2, 1 it will touch, and root 2 it will not touch here. Its y value is -2. And from root 2 to root 3, from root 2 to root 2 it will touch here, and root 3 it is -1. And from root 3 to root 2, from root 3 to 1 minute, root 3 to 2, from root 3 to 2 it is 0. So here it is 0, it is 0. And now for x is equal to 2 it is 1. For x is equal to 2 it is 1 somewhere here. So here you see that we have got 4 discontinuity point, 1, 2, 3, 4. There are 4 discontinuity point. So f is discontinuous exactly at 4 points. So your here option, this will be B is your option correct, because here you see that 1, 2, 3, 4. There are 4 discontinuous points. So from this I can conclude that there are 4 discontinuity point for the function. This is greatest integer function. So this is the so how to proceed it, the technique lying behind it. See, main important point here, your domain, it is given to you, And since the domain is given to you, so my main objective is to make a greatest integer function. So squaring both sides, I got 1 by 4. Because it is a greatest integer function, I am going to consider as y, the value of y will be always integer. So nearest to 1 by 4 is 0, so I have considered is 0. And here that is minus 3, so minus 3 is added. So because this is the greatest integer, so our integers will be minus 3, minus 2, minus 1, 0. So this your greatest, this integers will be, these are your result. For minus 3 result, your x is this. For minus 2 result, your x is this. For minus 1 result, your x is this. For 0 result, your x is this. And for 1 result, your x is this. And so from here we see that function is discontinuous as 4 points, so it f is discontinuous exactly at 4 points. Now next I am going to discuss about the differentiability of the g function. Now what I have done is that for the first question I have written it for you, that is for the first question your fx, for fx, that is your, it was your greatest integer function, x square minus 3 greatest integer function. For x greater than equal to 0, your fx was minus 3. For x greater than equal to greater than 1 less than root 2, your fx is minus 2. And for x greater than equal to root 2 and root less than root 3, your less than root 3, it is minus 1. For x greater than equal to root 3 and less than 2, greater than equal to and less than 2, here this is less than root 3, less than root 3. This is your fx is 0, and for x is equal to 2, your fx is 1. So here this was the result which I got in your first section, and this result I have written it for you. Now for gx, this gx function is this one, your gx function. Your gx function is modulus x and then fx, modulus x fx plus modulus 4x minus 7, 4x minus 7, 4x minus 7 modulus fx. So again for this separate 1, 2, 3, 4, 5 for 5 cases, there will be 5 cases here. So for here, that is your case 1, for case 1, that is x greater than equal to 0 less than 1, for this your fx is equal to minus 3. So here your gx will be how much? This is minus 3 modulus x, and plus here this is minus 3 modulus 4x minus 7, this. Now again for case 2, your gx will be how much? This is for minus 2, that is, sorry, let me write the interval. For x greater than equal to 1 and less than root 2, your fx is how much? Minus 2. So here your gx will be equal to minus 2 modulus x and plus minus 2 4x minus 7. And again for case 3, that is for case 3, this is your interval. So x greater than equal to root 2 less than root 3, your fx is equal to minus 1. And so here your gx will be minus 1 modulus x and plus minus 1 and then 4x minus 7 modulus. Now here your case 4, this is your, for case 4 x is greater than equal to root 3 and less than 2, your fx less than 2, your fx is equal to, this is fx is equal to 0. So here your gx, see your gx fx here is 0, 0, so your gx will be 0. And for case 5, your case 5, your x is equal to 2, fx is 1, so here gx, your fx is 1, so your gx will be modulus x and plus 4x minus 7 this. So from this these are the gx, these 5 they are the gx. From here now I am going to find out the gs function. So your gx, first for case 1 you see that your gx in this interval x will be positive. In this interval your x will be positive, so this is this will be minus 3x, and again minus 3 here. See, you see in this interval this whole value will become negative. So this whole value will become negative in this interval. You can see, because 4 into anything within this interval is less than 7, so this will come to be negative. So the result will be negative, so we will consider the negative part. And so here this will be minus plus, so this will plus 4 3s are this will be 4 3s are 12x 12x plus minus 21, because here you see minus 3 and then minus 4x minus 7, so this will be 4x minus 7. So here your result will be this. From here we are going to get how much? 12 minus 3, 12 minus 3, that is 9x minus 21. So your gx will be 9x minus 21. Now again case 2, in case 2 you will see that in case 2 here your gx, again in this interval, say in this interval this will be positive, so this is equal to minus 2x, and then again in this interval your this whole result will be negative. Your result will be negative, so I am considering the negative part of it. So this will be plus, so this will be 2 into 4, that is 8x minus 14. So this comes out to be how much? 6x minus 14. So your gx will be 6x minus 14. In case of case 3, here you see case 3. In case 3 your gx, here you see in this interval again this x is positive, so this will be minus x. And then again here you see in this interval again, because root 3 value is 1.73, so 1.73, so this result will come out to be, the whole result will come out to be negative, because this whole result negative. So I am considering the negative part, so minus into minus plus, so this will be plus 4x minus 7. So here this will be 3x minus 7, and your gx will be 3x minus 7. And in case of case 4, here you see that here you see that is gx is 0, so here this is gx is equal to 0. This is case 4, sorry, case 4. And in case 5, you find that this is positive and this will be also positive, so this will be gx will be equal to x plus 4x minus 7. So this gx will be equal to 4x plus x plus 4x, that will be 5x minus 7. So the result, what we got, the result, that is gx, we got how much? 9x minus 21, gx we got 9x minus 21 in the interval that is this one, first one, x greater than equal to 0 less than 1. And again gx, what did the gx got? I got this is equal to 6x minus 14 in the interval where in the interval x greater than equal to 1 and less than root 2. Again gx, that is I got the value of how much? That is equal to 3x minus 7, where in the interval, that is x greater than equal to root 2 and less than root 3. And now this, and gx is equal to 0, where did I got? I got in the interval, that is x greater than equal to root 3 and less than 2. and last, that is gx, how much did I got? That is equal to 5x minus 7 in the interval where x is equal to 2, for x is equal to 2. So this is the result which I got gx here. This is the result which I got, this value of gx. So considering all these factors, this is the result which I got here. Now I have got the gx. Now I am going to test the differentiability of this of gx. So from here you see that your gx, see, it is from gx, here you see that is at 1, this is 1.2 function, and root 2 another function. So again root 3, here say root 3, and here you say 2 and 2, here you see less than, at this means there are testing point is this 1, root 2, root 3, and this root 3, and then this 2, your testing point. See, there are 4 testing points to check the continuity of the function gx. These are the 4 points to check the continuity of the function gx, and continuity of the gx. So from this we can see one, there are 2 functions, this is 2 functions. So if you see that here when x tends to 1, left hand side x tends to 1, and here x tends to 1, the results will be different. And again for x tends to root 2 and x tends to root 2, from left hand side right hand side, you will find that the results will be different. Similarly for root 3 and for root 3, your results will be different. And similarly for 2 and left hand side and right hand side, you are going to get 2 different answers. So from this it is clear that, you can conclude that, I am again repeating here, you see that for 1, these are the testing point where your graph changes your positions. These are the testing points where your graph changes your position. See, because from left hand side it will follow this graph, and from right hand side it will follow this graph. If you test for limit 1, if you test for limit x tends to 1, so for minus 1 and for limit x tends to 1 plus. From this you see that, here you see that these are the 4 testing points, and in these 4 testing points you find the, for x tends to 1 minus, for left hand side this will be your function, for right hand side this will be your function. If you place 1 here and if you place 1 here, you see the results are different. Similarly will be the case for root 2 and root 2 and root 3 and root 3, 2 and 4. So there are 4 points of discontinuity. So since the functions has 4 points of discontinuity, so it has 4 point of differentiability. So we, at this point, because it is not continuous, these are the points where which we can't differentiate it. These are the points where which we can't differentiate it. So as there is 4 point of discontinuity in gx function, so as there is 4 point of discontinuity in gx function, so naturally there will be 4 points of discontinuity for gx. So this C option will be your answer. So this is the answer of this question.